Good morning or good afternoon, everyone. Thank you for joining us today. My name is Laura Kennedy, and I'm CEO at Global Power Technologies. Today's webinar is intended for end users who are interested in learning about TEGs or thermoelectric generators. I'm joined today by Brian Miller, who is our engineering manager, and Adam Stosky, who's our product manager, and they'll be helping me present our slides today. So this is a Zoom webinar. We are doing a video recording, and there are live AI captions that are available with translation through the Zoom webinar tools. We will be having the video sent out once we're done the presentation, and a link will be sent. And in that video, there will be subtitles available in English and Spanish. We'll be holding our questions till the end of today's webinar. So you can use the Q&A button in Zoom. If you don't see that Q&A button, if you click on the circle with the three dots for more, you should see the Q&A option there. And please type in your questions and we'll get to those after the formal part of the presentation. So in our presentation today, we'll tell you a little bit about Global Power Technologies, and then I'm going to hand it over to Brian to help us describe what is a TEG or thermoelectric generator. We're going to talk about some of the most common applications for TEGs, some sizing considerations if you're considering purchasing or determining which model of TEG that you need, and then Adam is going to help us wrap things up with some case studies. So very briefly, we've got a pretty cool history to our company, which is that the technology of a thermoelectric generator was designed by NASA and 3M at the time of the Apollo mission. And the goal was to provide unattended power generation for decades on the moon. So GPT took that technology and applied it to natural gas and propane driven thermoelectric generators for the oil and gas industry worldwide. So fast forward in the past 5 years, we've extended our power generation activities to include other products for higher power generation, as well as methane reduction solutions. We currently offer sales in most continents around the world through a network of agencies or channel partners that help us provide both sales, service, and parts into those regions. We've served almost every major energy company and pipeline that can be named, but we've just highlighted a few of those here on the bottom left. So Global Power Technologies is based in Calgary, Alberta, and we have a factory in Bassano, Alberta as well. We manufacture TEGs is the heart of our business, which is what we're talking about today. But we also offer solar TEG hybrid systems, instrument air packages, higher power packages called the MX, which can also be offered as a combined heat and power solution. We do fuel conditioning and gas pressure reduction, usually as a package together with TEG systems or MX power solutions. And we also have certified industrial panels. For field service training and support, we do offer training programs, and those can be registered for online. They are offered both in class, virtually in class in our shop in Calgary, or can be arranged in the field for your team. We do have in-house repair, and we're able to do custom projects, including engineering and document control. So just before we dive into TEGs with handing over to Brian, I'll tell you a little bit about the difference between our power generation options. So on the TEG side, we're focused on lower power generation from 5 watts up to about 500 or 550 for individual TEGs. It's native DC power output, and they can be combined together to create a multi-TEG system. However, we also have the MX, which has a higher efficiency in that higher power range that could also be considered as an alternative to a multi-TEG solution. The difference would be that the MX is a native AC output, and it is driven by an internal combustion engine rather than our TEG technology. We're currently working on a 14 kilowatt system, or MX, that is available for field trial this year. So if that's something of interest, please let us know. So I'm going to hand it over to Brian to start talking about the TEG advantage. And off you go, Brian.
Thank you, Laura. So the TEGs offer a lot of advantages compared to conventional generators. One of the advantages is that they're 99.9% methane destruction. They're very good combustion efficiency. We generate heat from that combustion, which powers the solid state thermoelectrics. They're proven in the field since 1975. We've had units in the field. Often they exceed 20 years life as long as you're doing proper maintenance and running them properly. So with the minimal maintenance and reduced operational costs, they're very popular in the oil and gas, midstream, and telecom industry. Solid state, meaning that the heat is converted directly to DC power with no moving part. That is what extends the life of the unit. So with the no moving parts, it can often last, as I said, 20 plus years, but it also means that maintenance is easy. There's not going to be like any wear and tear from conventional. It's more just long-term degradation of the unit over 20 to 30 years. And then what it can be done is paired with batteries for battery backup or solar PV hybrid. And on top of being paired with those items, it extends the battery bank life as well. So when the TEG is running, it float charges the battery bank. You don't see the batteries discharge as often, and they last a lot longer. So rather than having to replace them every 2 to 4 years, you're getting batteries last 5 to 10 years, much longer than typical. All this adds up to reduced site downtime and increased reliability, which is why they're used globally around the world. So we have our service team provide both phone support as well as site support all around the world. So we've had our technicians fly out anywhere from Canada, US, Southeast Asia, Australia, Latin America, Argentina, Mexico, you name it. We've probably been there. So very, very global outreach with our products, and they've been proven in the field for several years. Next slide. So how do thermoelectric generators work? Looking at the diagram here, they take natural gas or propane fuel and go into a burner, and it generates heat. So you can see you get basically uses the Venturi effect to the burner, which draws in air, generates a lot of heat, and then you have a hot side and a cool side on the thermal pile. So the hot side to the cool side has heat flux that generates DC power. That heat goes to the cooling fin, and we have a duct system which allows ambient air to be drawn through the cooling fins and up as rejected heat. So that hot to cold differential generates DC power from 5 watts to 500 watts, depending on the model. As you can see, there's no moving parts. It's just the flame being inside the burner. 20-year design life. We've had units reach up to 30 years in examples in the field. As I said, minimal annual maintenance, just looking at the regulator filters and checking the electrodes and certain components once in a while. And we've had over 40,000 units sold globally. So looking at an overview of our power generation technology and ranges, we have anywhere from 10 watt for the Sentinel up to 550 watts with the 8550 and 1500. The ones outlined in orange there are hazardous location tags. So those typically have additional features like flame arresters, exhaust coolers that make them suitable, that they won't cause, they are suitable to be in a hazardous environment. So they're very popular on sites where you don't have spacing. You can put the tag outside of the hazardous location or on offshore platforms where space is at a premium. So our most common tags, I would say, are probably our P tags, the 50 watt and 100 watt tags. Those are commonly used. And then as you get up to power, we got the Hasblock 100 watt tags. We got 5220, 8550, which are the cylindrical power units at 500 watts. as well as our 1500. Most common applications that these are used in are cathodic protection and SCADA. So anywhere on a pipeline where you don't have grid power or you need to send it along different places on the pipeline, they often impress current to anode bed, which prevents corrosion on the pipeline. We have our Sentinel used as a dual source power setting in an urban setting where they need critical power, backup power to even grid power, or dual power with solar. And speaking of solar, our TEGs are very commonly used as solar hybrid backups, or even as prime power in certain conditions. So, for example, in northern Canada, the TEG will be on in the winter, but in the summer they can run on solar hybrid when there's longer days and a lot of sunlight. Combined heat and power is another common application. Both our TEGs and our MX power can provide both heat and power. So often our TEGs are used in this combined heat and power, the heat recovery system, and the heat is able to be used to heat a building. So you can keep a building warm during cold temperatures while the TEG output continuously continuous power. And in warm conditions, it diverts the heat to be outdoors rather than inside the building. And then offshore power, as I mentioned earlier, our Haslock TEGs are marine rated. They use 316 stainless steel for their shells and outer components, and they are very commonly used on unmanned offshore platforms. And I'll hand it over to Adam, our product manager.
Awesome. Thanks, Brian. So one of the most common applications for our TEGs is actually using them for an impressed current cathodic protection. The benefit of using the TEG is that it's a native DC output. So we have a CP panel that is attached onto the TEG that allows you to adjust the voltage, operating the TEG in constant voltage mode, but you don't need to buy an additional rectifier like you would if it was grid tied. The TEGs have simple annual maintenance and can be done by any trained technician. And we often right size the power for smaller sites. So a lot of these sites are typically 500 or more watts or below. They do have quite good fuel efficiency at this power rating. So compared to a lot of the other remote power systems that are out there, say like a Stirling engine at 500 watts or below, we're actually more fuel efficient and use a much smaller footprint. In comparison to like a solar system with cathodic protection, we typically see there's less theft and vandalism, and we don't have the same issues that you see with batteries being stolen. We also have a shorter wait time than trying to bring in grid. So when you bring in grid to sites, lots of times it's quite expensive, and then it can take months to years to get the permitting in place. Next slide, please. So Brian kind of ran through the different sizing options that we have for our TEGs. So all the way from 10 watts to 500 watts. And when sizing your TEG, the two things that are most important for us is understanding what the peak loads are on your battery, and then also what your continuous load is going to be. We don't want to oversize the TEG for necessarily those large peak loads. You can use a battery in those situations. And we want to keep the TEG as small as possible, typically because it's more cost effective for the end user. And then you can always add units on top if you need to scale in the future. The other thing to consider is the location of your site. So if you're looking and you're placing the TEG in a site that's either very hot or at very high altitude, it affects the cooling of the TEG. So it doesn't produce as much power anymore. So for those situations, the derate curve does vary by model. So either look at the manuals online on globalte.com, or you can come to us and we can help you derate that TEG for those locations. The other situation in which location is really important is when you're doing the solar hybrid work. So you can also come to GPT and we can help you do a simulation. We have a software which will tell us how much solar radiance the location gets over the year. And then we can make sure that your TEG is not cycling on and off too frequently and that it's sized appropriately. The last kind of situation we want to look at is how close you are to special places like wellheads or process vessels. So if you're in a class 1 Div 2 area, you're obviously going to want to choose a hazardous location tag. And then there are situations in which you want to be within 25 meters of a wellhead. In those situations, you want to choose a tag that has a flame arrestor. So that's typically RP tags. But once you kind of understand what your power requirements are, you can always contact us to understand whether the tag has an appropriate flame arrestor or is hazardous location rated. Next slide, please. So we wanted to also include some of the success stories that we've seen from our customers. So one success story that we've seen in Southern US is there was an operator running solar systems in Texas and Oklahoma with just pure solar. What they were seeing is that they were incurring on total operating costs to replace either depleted or stolen batteries up to the tune of $1.2 million per year. So this really caused a lot of unplanned outages for them, and they were tending to replace these batteries all the time. What they ended up doing is converting these sites to TEG solar hybrids. The TEG does seem to deter a lot of theft from the area because there is now a hot unit that is running on natural gas. As well, it just stops the batteries from depleting as much in the winter when the solar radiance isn't as good. So initially, they were thinking that they would run the tag off of the depth of discharge of the battery. So you can run the tag so that it monitors how much voltage is being output by the battery, and it will turn on and off by itself to keep the battery topped up. Eventually, they did decide that it was simpler just to run the tag all the time. So the tag basically trickle charges the battery, and then the solar provides the extra power as required. So by implementing these tags, they were basically able to lower their total cost of ownership, and they kind of recovered that initial capital cost by reducing their incurred site visit and battery replacement costs. Next slide, please. Yeah, thanks. Another good story that we have is actually in Italy. So this customer was actually running all of their SCADA systems on only solar and wind, which wind typically could have a very intermittent operation. So they were seeing similar problems where they were having increased site visits and having going out to these remote locations. And the company eventually put in a mandate that they wanted to have zero interruption service on these locations. Since it was a pretty small site, they had less than 100 watts of power required. They actually added one of our P5050 tags. So the tag itself took up about 50% of the capacity or the required load capacity. And even that was enough to eliminate site visits and avoided those constant trips back to site. So they've adopted this company-wide for all critical sites, and that supports their solar and wind systems. It's connected right up to the same battery system that you would run the solar and wind system on. The last case study that we wanted to highlight is just a testament to the product life of some of these systems. So we have a 5120, which is what came before that P5100 tag model. So that was commissioned in 1987, just south of Calgary in the Drayton Valley area. It's been providing cathodic protection to a pipeline out there for about 30 years. So in 1996, it did get a new power unit, but then it ran for another 21 years with just regular annual maintenance. We did refurbish the tag back in 2017, and it has been returned back to the field and has been running since. So it's been running for over 30 years now at this point. And that's kind of all that we had for today. If you do have any questions, feel free to use the Q&A session, and we'll be able to answer those questions in that format.
Great. Thanks, Adam and Brian. I see we've got a handful of questions here, so some good topics to get started on. So maybe the first one, since we did sort of highlight that cathodic protection application for TEGs, one of the questions we have here is what makes TEGs applicable for cathodic protection, and how do they run a rectifier if a rectifier is needed?
I can take that one. So the reason that you don't need a rectifier for when you're using tags for CP is that it does produce native DC output. So typically we run the tags in like a constant voltage mode is what we call it. So there's a CP panel with tapped resistors on the side of the tag. You can adjust the voltage there to impress the current that you need for your cathodic protection. And that's kind of all you need to do. You don't need to convert AC power to DC power like you do when you're going from a grid tied system.
Great, thanks, Adam. And we've seen a lot of people adopting that both, historically as well as recently. We see people also who have rectifiers that are driven by solar and battery that just aren't reliable enough, where they're putting tags in to that ground bed that was previously provided by solar and battery, or the tag can be trickle charged directly to the battery for that cathodic protection. Brian, I think I'll pass the next question to you. We have a user who said they've been using TEGs since the 1990s and said it's an awesome power system. So thank you for that. The question here is about, do the power supplies today have any IP intelligence, such as SNMP monitoring?
Yeah, so our power units are fairly they have a lot of internal knowledge that how we make them, but we keep them fairly simple from standpoint of operating them. So we do have our own tag controller, which controls the tag both from gas safety and electrical safety standpoint. But we don't have anything that basically monitors the power unit. That's still a relatively manual way. Just on your annual maintenance, you just check the open circuit voltage and gives you kind of a good idea of what the power unit how it's performing, and you can check voltage and current when it is under load as well. So right now we don't have anything to monitor the power unit, but we do have some features that people can hook up the tags to their SCADA system, such as voltage sensing relays, take run status, those sort of things on some of our more modern models that that some of our customers use. They like to have at least a status and power output and voltage sensing on our tags.
Great. Thanks, Brian. Adam, I see a few different questions here about cost. So some of them are specifically around how tags compare with solar and PV systems on a, for example, per kilowatt basis. And another question that also asks to include what the installed cost might be. Can you answer that for us?
Yeah, so we typically find that in the kind of like 50 to the 100 or 500 watt range that our tags are competitive with solar systems when they're sized appropriately. We do find that a lot of solar installers skimp on the solar panels themselves. So we find that we need about, if you multiply it by 8 is typically what we see. So if you need 500 watts worth of power, you would need about 4,000 watts worth of panels to reliably supply solar, at least in northern Alberta. For cost per kilowatt hour, I think we're probably running around $90 to $100 Canadian per watt. And I'm not sure how that compares to at a kilowatt hour basis. I would have to sit down for that.
I think just to add to your thing about the solar comparison is solar is a lot cheaper if you already have kind of a grid system to tie to, where you can like sell it back to the grid. Where I find where the tags come in handy is that on an off-grid system, you need to have obviously a large amount of solar panels, but you also need a huge amount of battery banks, especially in northern climates where if the battery get cold, they lose a lot of their capacity. So to get uninterrupted 100% ultra reliable power, solar panels and batteries become massively large and expensive to both buy from a capital standpoint as well as to maintain and have to replace those batteries. So a TEG is very small footprint, and kind of just set it and forget it, especially in the winter months. So that's kind of where the cost benefit of a TEG comes in, is where you're off grid power. You don't want to bring in grid power. It competes really well, especially compared to solar and battery.
Great. Thanks, Brian. I might actually send the next question over to Brian, but Adam, feel free to join in if you'd like. So we have a couple questions around installation and maintenance. You know, how hard is it? What knowledge do you need? Are there special tools or special certified training requirements that people need to go through to be able to install and maintain a TEG?
Yeah. So typically we see most commonly these are installed by instrument techs or millwright in the field. They're relatively straightforward. You need basically, you probably need something. The TEGs kind of range from 100 to a few £100 on the flat plate, the kind of 100, 200 watt models, and then our 500 watt kind of range from a few hundred to 500 pounds, so a little heavier. So you need some equipment to be able to lift it and mount it onto a stand or a pole mount system. We do provide stand and pole mount systems if you guys require. Once it's mounted on site and appropriate anchoring and civil works, it's relatively easy to hook up. You need to run instrument gas to your TEG, so fuel gas. It's an NPT connection. Often people just run wage lock adapters and connectors to the TEG and run tubing. Typically 15 psi fuel gas inlet. And then for power output, you just run basically wires or cables to the TEG to your load, whether it's a battery or SCADA system or whatever you have on the site, and that will since it's low voltage DC power, relatively straightforward to do. There's not it's very easy to access terminals on the TEG. So basically, you just need basic setup from an instrument tech to run some fuel lines and cables, and then on the startup and commissioning, there is maybe a little bit of understanding of the combustion of a TEG, which is easy to explain in the manual. You just adjust the air-fuel ratio if needed. You try to maximize power output on the TEG, but you also don't want to run it overheated. So we basically say run it at this certain range of fuel pressures. So you have 15 psi in, for example, and then the regulator on the TEG, you would regulate it down to, on the P5100, 4 to 6 psi. Once it's set to the power you want, which comes to power in about 20 minutes, you basically ensure that combustion is okay, and you would basically set it and forget it. And then once a year, you would check on the unit to make sure it's still outputting the power.
Great. Thanks, Brian. Adam, we've got a couple of questions around solar hybrid. I was wondering if you could talk a little bit about what the process is for us to size and recommend a system for solar hybrid. And there's also a question related to what battery chemistry we prefer when we're doing solar hybrid.
Yeah. So typically for the batteries, we'll use lead acid gel batteries is what most of our clients use, but we have worked with other chemistries in the past. For our solar hybrids, we kind of operate them in 3 different ways. So the first is the same way that you saw with that producer down in the US, where you just run the TEG consistently. It'll trickle charge the batteries, and the TEG has an internal resistor to dump any extra load to. The second way that we've seen people do it is that they run it when their radiance is poor. So they'll turn it on in the fall, support the solar system while the radiance isn't very strong, and it tops up the power required from the solar system. And then the third way is that we have what we call a TEG controller. So that TEG controller will monitor the depth of discharge of the batteries, and it will turn on and off the system as required. If you're looking to implement that kind of system, it's best if you come to us and we can run a simulation in our Homer software. What we don't want to do is cycle the TEG on and off a lot. It causes the power unit to degrade faster than we typically want to see. And so we'll size the TEG system and we'll give you a recommendation on the solar size as well with that Homer software.
Great. Thanks, Brian. I'm going to ping the next question to you. It's specifically around how TEGs are operated in parallel and whether you need to think about anything like synchronization or load sharing when you're doing that.
Yeah, great question. Because the TEGs are DC output, they're very easy to run in parallel. You don't have to worry about synchronization at all. So as long as your TEGs are the same voltage output, so you wouldn't want to mix a 24-volt TEG with a 12-volt TEG, for example, but if they're both 24-volt TEGs, very easy to run in parallel. The other thing we recommend doing while running in parallel is making sure each individual TEG output voltage is set to about the same amount. You don't want one running at like 27.2 and the other running at like 26 point something. You'd want them both set at 27.2 so they're both outputting about the same power. Otherwise, one will be working a little harder than the other. So you just want to try and kind of balance the voltages so they're both, all the TEGs are trying to output the same voltage, and they should then output about their share of the power equally.
Great. Thanks, Brian. Adam, I'll get you to take the next one. It's about using propane on a TEG. So are there any estimates available for sizes of propane tanks or how often they would typically be changed? And also a question if it's in the north or at what temperature do we recommend some kind of heat for those propane installations if the temperatures are cold in the winter?
Yeah, it's a good question. We typically see people have those really big bullets or built for the propane units up in northern Alberta. And then on the heating side, we typically ask people to work with their local propane provider because they'll have a lot more knowledge on what is required and what the options are for their propane bullets. We do have consumptions of each of the TEGs available on the spec sheets. So if you go to globalte.com, there's a document archive. The spec sheet for, say, the 100-watt TEG or the 50-watt TEG will have the fuel consumption of the propane consumption for each TEG.
Great. Thanks, Adam. Brian, the next one we have is a specific one for hazardous location areas where if clients are concerned, for example, about the presence of a flame source, how do we help them understand the certifications that we have and the safety assurances in the design of those TEGs so that they can safely operate in those conditions?
Yeah, so our HazBlock TEGs, that's our Sentinel 10-watt TEG, our 1120 100-watt TEG, and our 1500 500-watt TEG, they're all certified to Class 1 Div 2 hazardous location, and with a temperature rating of 200 degrees Celsius. So that means they're suitable for almost any hydrocarbon, natural gas, or even some hydrocarbon liquids that could be vapors in the area. So we do know that they passed the certification test, and can be exposed to those environments, even though there could be a flame in the TEG. So our Sentinel is actually using a catalytic heater as a heat source, so there is no flame there. But for our 1120 and 1500 TEG, there is a flame inside there. So how it's designed so that it can handle these hazardous environments in an offshore platform or any hazardous environment, is that we have both intake and exhaust flame arresters so that it's impossible for the flame to propagate outside the burner. It gets quenched by the flame arresters, even at high temperature, ambient temperatures. The other thing we do is we have an exhaust cooler. So the exhaust cooler ensures the exhaust gas stays below 200 degrees Celsius at all times, even at high temperatures. And so that way that there's no way, even though there's a flame internal to the tank, there's no hot exposed surfaces, and there's no way for the flame to propagate out or the exhaust to cause an ignition because of the low temperatures. We can provide some case studies. We've sent them on several offshore platforms in US, India, Southeast Asia, Malaysia, Indonesia, Thailand. And we've had hundreds of TEGs deployed in these marine offshore environments in hazardous location platforms. So we'd be glad to provide more case studies on that.
Thanks, Brian. There is a question about customer support outside of Canada. So I'm just going to jump back up to our slide with the map on it. So we do use channel partners and agents to provide, as I mentioned, both sales and service globally. this map gives an indication generally of where they are. It's probably not specific, but gives you an idea of coverage. But I would say if you or someone you know is looking for support online on our website in our contact us area, there's both an email address and a phone number where you can reach our technical service team during working hours. And they'll respond to you and help you as they can by phone. And when that's not possible, we'll either recommend a local reseller, local agent that's trained in the area, or there is an option for our field service technicians. They have the qualifications required for both onshore and offshore in almost every region in the world to be able to do a field site visit if that would be required. Let's see, Adam, maybe I'll pass this next one to you about whether raw gas at a wellhead can be used, or what we would look at in the fuel composition to determine whether either gas pressure reduction or fuel conditioning might be required.
Yeah, so a lot of our installer locations actually do use raw gas. Like you said, it does depend on the fuel composition itself. So we've seen areas that either have high CO2 concentration or H2S concentration. So in those areas, we do have fuel conditioning systems that we use. Typically, those are installed on like an offshore platform. Wetness is also an issue, so we don't want to get any liquids into the TEG. So that they also have to be knocked out. So you can use either, some people will use a small knockout pot, or if it's really, really wet, then they'll have to use something different. We also, for our midstream clients, typically have what we call like a gas pressure reduction system. So they'll do a hot tap right into the transmission line, and then we have our own system to drop the pressure down to fuel pressure for the TEG itself. There is a fuel specification as well on the website that has the detailed parameters of the composition that we kind of require.
Great, thanks. I think we'll wrap with one last question then. Brian, can you answer, we talked about derating in higher temperatures, but how would somebody understand what derating curve or information they need to use?
Yeah, it's easily available in our website. If you go to our manuals, if you go to our website, there's the document archive. You can pull up any manual spec sheets of all our TEGs and other products. In the manuals, it'll show that the TEGs have a derate of a X number of watts per degree Celsius. So the rating of our TEGs is typically at about 20 degrees Celsius. So for example, our P5100 is a 100 watt TEG rated for 100 watt at 20 degrees Celsius. And it has a kind of a derate of 0.4 watts per degree Celsius. So if you were to run it at 40 degrees Celsius, you times that difference between 40 and 20 times 0.4. So that's about 8 watts. So I would say between you'd have 8 watts loss of power between 20 degrees Celsius and 40 degrees Celsius at high temperatures on a 100 watt TEG. So that's just something to keep in mind. And then our TEGs range from 0.2 watts per Celsius to 1.4 watts per Celsius on the 500 watt TEG. So it depends on the model of TEG on that range. But all that information can be found on our website, or if you reach out to us, we can provide specific for your ambient conditions.
Great. Thanks, Brian. Thanks, Adam, for your help. So on our final slide here, you can see both our website where there is full information, specifically under the products tab. You can dig into the TEG information and find the required documents that you're looking for. But if there's any other questions, any support required, if you're not sure who's in your region to be able to support you, please send us an email at gptsales@globalte.com. And we'll make sure either we answer your question directly or get you in touch with the right person to answer that question. Thanks again for joining, and have a great day.